Good morning, students. So till last class we discussed about the characteristic features of GPIB, that is your IEEE 488 or IEEE 488.1 interface system. Now today, and I also illustrated with one example that how GPIB, the controller and instruments communicates to each other in GPIB configuration. So today I would like to discuss the pin diagram of IEEE 488 bus. So it is of 24 pins. Among those 24 pins, the 8 pins are initialized for the data buses and 5 is for control bus lines, and 3 for the handshake operation. So one by one I will discuss in detail. Okay, so first of all, the pin number 1 is data 1, pin 2 is data 2, pin 3 is data 3, pin 4 data 4, 13, 14, 15 and 16 are also data bus lines. So total we have 8 data bus lines. If you can see, pin number 1 to pin number 4, pin number 13 to pin number 16, we have 8 data bus lines. So here data lines, GPIB has 8-bit data bus and have 8 lines for sending data from talker to listener. So any data which talker want to send to listeners, so that will be sent through these data bus lines. Okay. Now next is our bus control lines. So bus control lines are needed in the system for controlling the operation of the system or controlling the flow of the data management, which is from the controller to the listeners or from any other talker device to the controller. So this operation is being controlled with the help of 5 control lines, which are being operated by the controller. So 4 are being operated by the controller. So let's see one by one its operation. So what are these lines? These lines are ATN. I made the star on those lines, on those pin numbers. Pin number 11 ATN, pin number 10 SRQ, service request, pin number 9 interface clear, and pin number 5 EOI, and pin number 17 REN. Okay. So what is ATN? ATN is attention, IFC is interface clear, REN is remote enable, and SRQ is service request, and EOI is end or identify. So there are total 5 bus control lines. So one by one I will discuss the operation of these commands. Now ATN is what? Attention. Attention is if attention signal is 1, high or true, in that case system places all the devices in the command mode. That means the controller will send the messages to the devices which are connected on the bus network. So it is in the command mode. Like it will or we can say that it is in addressing mode also, because at that time the different devices which are connected on the interface bus, so all the devices have their unique listener address as well as their talking address, each of the device. So when ATN is 1 or true, at that time the controller will initialize those devices with their specific addresses to communicate with them during the operation. Okay, so at that time it is in the command mode. At that time when ATN is true, it is in the command mode, where the controller can only send the messages to the desired devices or the specific devices to initialize their address location. Now when ATN is equal to 0, when ATN is 0, in that case, or ATN is false, in that case system places all the devices in the data mode. Data mode means at that time the talker can send the data on the data bus, and the receiver can have to receive that data and read that data or that instructions which is needed to pursue. So when ATN is 0, so system places all the devices in the data mode. That means a controller or the talker can send the data on the data bus, and it once the data is being transmitted, then the receiver can read that data, okay, or the listeners can read that data. So this is the operation of ATN. I hope it is clear to everyone. Now next is our IFC. IFC is what? Interface clear. Now again, interface clear command is also being operated by the controller itself. It is used to halt the operation in between, or to abort the operation in between due to certain other abnormal condition occurring in the system. So for that, this interface clear command is used. So logic high means all the devices on the bus are reset to their initial states. So this is done by the controller to reset all the devices to their initial state and to start the operation as a fresh. So this interface clear command is again used by the controller. Now next is REN, that is remote enable. So remote enable as the name describes, remote enable means as the logic high will be there when REN is equal to 1. In that case, all the devices which are connected to the network, all the listener devices, they are capable to go into the remote control mode. Okay, so it will be going into automatic mode. When it will be logic 0, when REN is equal to logic 0, or it will be low, in that case it will be manually operated. Those listener devices are manually controlled. Okay, so this command is also clear. Now next is our SRQ. This is the SRQ. SRQ is what? Service request. Service request means, service request is interrupt signal. So SRQ command is being operated by the devices or the listeners who are connected on the network bus. So if they want to, if they send the interrupt signal to controller, if they need the service, any service to be, any service required from the controller side. So they just send a request signal to the controller for their services. Okay. So this is being operated by the listeners. Now next is your EOI, which is end or identify. Now EOI operation, this is your EOI. So EOI end or identify. So end or identify operation works in the combination with ATN command. Okay, it works in the sync with the ATN command. So when ATN is true, in that case, system places all the devices in command mode. So when ATN is true, then EOI will execute the polling sequences or the set of programs for the controller. Okay. When ATN is 0 or in the false condition, in that case, a talker can place the data byte on the bus network, and once it has been transmitted, then it can send the end signal to show that the transmission has been done, the data has been transmitted. So in this way, the EOI also operates in two modes, when ATN is true and when ATN is false. So when ATN is true, it executes the polling sequences, okay, one set of programs, software program for the controller, and if it is 0, then a talker can send the data or can place the data on the data bus and for the transmission. Okay, and once the transmission is done, it will be sent, the device can send the end operation. Okay, now next, all the 5 bus control lines has been covered. Now I come to the handshake lines. Handshake lines are DAV, NRFD and NDAC. So there are three handshake lines which are used for the successful data transfer being done from the talker to the listeners, and to make sure that listeners are receiving the data, and once they have received the data, they are reading the data, then the next data will be sent, or the next command will be sent to the listeners. Okay, for that purpose this DAV, NRFD and NDAC signals are used. Control lines are DAV, NRFD and NDAC lines are used. So let's see. DAV is data valid, so it is controlled by sender, talker or listener to indicate valid byte is present on the data input output line. So it indicates that valid data has been placed on the data bus line or data input output line. So acceptor is now ready to receive that data. So for that DAV signal is low. Once the DAV signal is low, that means valid data byte is placed on the network and ready for the acceptance. Okay. Next is your NRFD, which is not ready for data. Not ready for data, that means if it is high, in that case it is not ready for data. If it is low, that means it is ready. So signal goes high when all the devices on the bus are ready to accept the data from data input output line. So when all the devices are ready to accept the data, that means all the listeners are ready to receive the data. If some of the listeners were executing the previous instruction, so in that case NRFD will go low because all the devices are not yet ready. So when all the devices are ready and the previous instruction is performed, after that they all are ready for the next instruction, then the NRFD signal goes high. Okay, when all the devices on the bus are ready to accept the data from data input output lines. Now the third is no data accepted. No data accepted, that means it is used by acceptors. That means this command is used by the acceptors, which are your listeners. Acceptors means, acceptors are what? Listeners. Okay. So it is used by the acceptors or listeners to indicate that data byte has been received. So the data byte has been received. That means that data byte has been received. So NDAC, when high, then data has been accepted. When low, that means no data is accepted yet. Okay. So these three functions I'll show or explain you through the signal flow diagram. Then it will be more clear that how these DAV and NRFD and NDAC performed. So then it will be more clear to you, but that I will discuss in the next class. Okay, that I will discuss in my next lecture. So till here I have covered, till now I have covered the pin diagram description of IEEE 488 bus interface system, that is GPIB interface system, which consists of 24 pin diagram, where the 8 is your data lines, data input output lines, and 5 is your bus control lines, which controlling is being done with the through the controller, okay, on the bus network, so that flow of information can be shared smoothly. Then handshake lines. Handshake lines are the handshake operation is done between the talker and the listener, that when data has been transmitted to the listener has received, then it acknowledges, yes, I have received the data, then next set of data will be placed on the data bus line. So in this way, this is the handshake lines which are used so that data transfer can be done smoothly. So this is performed with the help of the three lines, DAV, NRFD and NDAC. So which are here at the pin number 6, 7 and 8. And your 18th, 19th, 20th, 21st, 22nd, 23rd pin are the ground with DAV, ground with NRFD, ground with NDAC, ground with IFC, ground with SRQ, ground with ATN. And 24 pin number is your signal ground. So I have explained you the function of each and every command there. on the pin diagram. So I hope this IEEE 4-rated bus pin diagram is clear to you. In the next class, I'll discuss the handshake operation with the flow chart, with the signal flow diagram. So it will be more clear to you. Okay. So thank you.